ijk times epsilon mn k equal to delta im delta jn minus delta in delta jm. Okay, what have you done so far? Like where did you start?
I didn't know where to start.
Okay, anybody has any hint what to do for as the first step? Anyone else?
Summation over K.
You want to do summation over, wait, did it say epsilon m and k? Okay, so summation over k. So this is, I'm just starting with the left side. Epsilon ijk, epsilon m and k. We'll write k is the repeating index. So we'll write this is epsilon ij. We'll expand over k. So this is going to be epsilon ij1, epsilon mn1 plus epsilon ij2, epsilon mn2 plus epsilon ij3, epsilon mn3. Then what did you do?
For the epsilon ij1 and epsilon mn1, I took out a matrix.
So what do you mean by I took out a matrix?
Like we have even permutations and odd permutations.
Okay, so firstly, before we do that, just as a hint to everyone, if you go to page 22 of the textbook, there is a hint that the book suggests to start this problem. So Mark, first, if you just look at the book, page 22, the first at the top of the page, the following relation is referred to as the epsilon delta identity, which is given as epsilon ijk, epsilon mnk equal to delta im times delta jn minus delta in times delta jm. This relation can be obtained from the determinant relation equation 2.7 for the special case of A equal to I. So that's the hint given in the book, which I'll write. This relation can be obtained from the determinant relation for the special case of A equal to I. That's what is given as hint in the book. Yeah. So what is that determinant relation? So that is equation 2.7, which gives the determinant or determinant of A is equal to, you can write that as epsilon ijk a1i a2j a3k. This is the formula for the determinant. Equation 2.7 goes one step further and multiplies both sides by epsilon mn p times determinant of A equals epsilon mn p epsilon ijk times sorry, this is equal to epsilon mn p. This is equal to epsilon ijk times aim ajn anp. This is what equation 2.7 is. So if we start with here and then set A equal to I, we can get this relation. That's what the book suggests. Okay, so let's see how we can do this here. These identities can be proven by substitution. Okay, so let's try to use this relationship with A equal to I. If A equal to I, what is determinant of A? Equal to 1, because I is the unit tensor. Determinant of that unit tensor will be 1. So this relationship would be epsilon mn times 1 equal to epsilon ijk times aim a jn times a np. But these quantities are either 1 or 0, because we chose the tensor A to be the unit tensor. Now can we do something to get back the identity that we want to get? What do we want to get? We want to get epsilon ijk, epsilon mnk equal to delta im, delta jn minus delta I n times delta jm. How do we go from here to here? Any thoughts? And we'll come back to that idea of expanding the matrices to see if that also provides a clue. But before that, I just want to try what the book says. Any thoughts? Anyone? Okay, I'm going to try something here. So we have the relationship for epsilon mn p, which is epsilon ijk times, what is aim? Aim is nothing but delta im. Why? That identity matrix or identity tensor has only elements 1 or 0. So A can take only values 1 or 0, and it will take the value 1 only if I equal to m. Otherwise, it's going to take the value 0. So I can replace AIM with delta IM, AJN with delta JN, and ANP with delta NP. Can I do this? Yes, no? Can I do this? Do you agree with this step?
I guess so. So that's why we did the identity matrix, is for the simplification.
Right. So to recap, we start with this relationship. We take this relationship. That's what the book suggests. Start with equation 2.7. And A is any tensor, any matrix. Choose a special case where A is equal to the identity matrix, which is, if you recall, this is 1, 1, 1 along the diagonal, and all other elements are zeros. So the elements of A, like A11 is 1, A12 is 0, and so on. So you can replace this A, or you can write A as basically equal to delta ij ei ej. That's what I've done here. That's basically like saying A equal to I. So then if I start with this relation, epsilon epsilon m and p times determinant of A is going to be 1. is equal to epsilon ijk times these terms. And then I'm saying these terms are nothing but delta functions themselves. Okay. So then I have epsilon mnp, just rewriting it here, epsilon mnp equals epsilon ijk delta im delta jn delta np. What do I need? I need to do this, or I need this quantity, ijk times mnk, ijk times mnk. So I'm going to write epsilon ijk times epsilon mnp equals epsilon ijk times delta im delta jn delta np. Okay, and then I'll multiply both sides, delta ijk mnp times delta kp equal to delta epsilon ijk delta im delta jn delta np delta kp. I'm just multiplying both sides by this quantity, and then before that I multiplied both sides by this quantity. So my left side is going to be epsilon ijk epsilon mnk. And what's going to be on my right? I'm going to have epsilon ijk oops, one second, sorry. So I'll have epsilon ijk epsilon mnk equal to epsilon ijk I have to set k equal to p, right? So this is delta im delta jn delta nk. Wait, not n, that's not correct. Im jn np, or no, there's some mistake. Kp, right? This kp. Yeah, pk. So this I made a mistake here. This must be kp. Okay, so I'll delete this, and this is kp. This is kp. So I have delta kp here, which means delta kp I have delta np delta kp. So I already have a delta kp here. I did multiply both sides to get this mnk and ijk. So I would have delta kp squared. Delta kp squared. Okay, now what do we do? Any thoughts? We did see a few other indices before. Delta ijk times delta ijk equal to 6. This is one of the identities we saw before. Okay, can we use that here? That's one question. The other question is, delta kp. Okay, this is not going well. Let's come back to this. Okay,
Did we not have to multiply both sides by delta kp now that we already have kp on the right side?
So you're saying just stop at this step and not do this step?
Maybe, that's just
Yeah,
my
okay.
guess.
Yeah, let's try that. Okay, let's try that. All right, we are at this step here. We are at this step here. So, okay, what do we do now? Can we? This relation can be obtained from the determinant relation for the special case of a equal to I. That is the hint. Determinant of A. Let's keep thinking about this. I want to just keep going. We'll revisit this problem within the hour. Okay. I had some notes. I just need to look it up and we'll come back to this. Is there another example that we can try in the meantime? Okay. Before I go forward, somebody else had a suggestion. What was the thing that you wanted to try? You want to prove this by brute force expansion? Is that what you were trying by expanding in terms of m and n? Okay.
No, sir, I would take IJ values as 1, 2, as 2, 3, and MN values as 2, 3, and go on with the expansion.
So you'll prove like there is a numerical value for the left side and a numerical value for the right side and show they are equal.
Kind of, yes.
Okay. We can certainly do that. I'm just trying to look for a more elegant way to do this. Okay, so let's revisit this within the hour. What else can we do first? Other than this?
I have an idea maybe.
Yeah.
From number 2, I remember that epsilon MNP times epsilon MNP is equal to 6.
Yep.
Can you simplify epsilon ijk in that way?
You want to write this as 6.
Yeah, would that help at all?
That is, if you just had this, yes, we can write it as 6, but we also have it multiplied with a bunch of other quantities. So before I say yes, I just want to think a little bit. All right, so determinant of A. Yeah, I suppose we can do that. Okay, so if we do that, this is 6 times delta IM, delta JN, and delta KP. That doesn't lead us anywhere because it's none of them are repeating, so we can't do any summation. Let's revisit this, I promise. Okay, let's try a few other easier examples and make sure we cross the list before we spend the rest of the time on this problem. Any other question that you guys have been trying? What about 2.3, 2.4, 2.5? Have you tried those?
Also, yeah, I have a question. 2.3, number 6. I didn't know how to simplify this one.
Okay, so let's try that. So you're talking about problem 2.3. I'm sorry, 2.3.
Yeah, number 6.
Number 6. Epsilon ijk ai aj
AJ,
ak.
AK.
Right. Um, so firstly, what does this represent? Is it like writing um, matrix of A, or is it like A cross A dot A? Is it so if you take A cross B, this is I'm sorry, yeah, E1, E2, E3, A1, A2, A3, B1, B2, B3. So you can write this as A cross B is epsilon ijk AI BJ EK. This is shorthand for writing this. What you have here is AI AJ AK. So if you take A cross B dot A, that would be epsilon ijk AI BJ EK dot AL EL, which is epsilon ijk AI BJ AL or AK. Are you with me so far?
Yeah.
Okay. So you can also make the choice that vector B or choose vector B equal to A. You can make the choice to make AI BJ AK, or even otherwise, even if you don't make the choice, this this quantity is 0. So whenever you have something that is epsilon ijk AI AJ BK or epsilon ijk AI BJ AK or epsilon ijk BI AJ AK, I'm saying all of these will be 0.
Oh, can you explain it again?
That is okay. Let me. So you understood this point, A cross B for any two
Yeah.
vectors.
Yeah.
So you take A cross B and then you dot it again with A. B is some arbitrary vector. A cross B dot A.
Equals 0.
That is always 0. This is always 0. We agree on that.
Yeah.
You can write A cross B if you write it in index notation. That will be epsilon ijk AI BJ times EK.
Right.
How did
And
you know
then
to cross it?
so the cross product, how do I know this? So if I refer you to one of the identities before. Somebody is trying to enter. Just 1 second. So if I refer you to page 22, I think again 21. Yeah, page 30, equation 2.29. Refer to page 30, equation 2.29 says A cross B is equal to epsilon ijk ai bj ek. That is same as writing E1, E2, E3, A1, A2, A3, B1, B2, B3. So I take this as my starting point. If you go one equation next, that is equation 2.30 of the same page, A cross B dot C gives me epsilon ijk ai bj ck. Are we together so far?
Yes.
Yes, Mark?
Yes. Yes.
Yes.
So now we are required to think about epsilon ijk ai aj ak, which you can just choose B also equal to A and C also equal to A. So you will be getting sorry, the right side at least, epsilon ijk ai aj ak is A cross A dot A. You can look at it anyway. A cross B dot A is 0. A cross A is 0. Dot A is also 0. So you can see it either way. Whichever way you look at it, this is 0. So epsilon ijk ai aj ak is 0. This is a useful result to have, or to kind of start or remember that A cross B is basically the permutation symbol with the components of the two vectors multiplied by the third direction K. So I, AI, BJ, EK. Okay. So going back to the problems, we were talking about problem 2.3. Anything else that we can try there? Do you want me to give it a try?
Do you mind going back to the last slide real quick first?
Sure. This one?
Or the next slide? Yeah, that one. Thank you.
This one?
7th slide.
7. Okay.
Thank you.
Yeah. Okay. All right. So that was from problem 2.3. If I look at problem 2.2, it doesn't look very challenging. It's basically using index notation. And 2.3 is to simplify. We just did problem 6. If I look at problem 2.4, write out the following expressions in indicial notation if possible. Have you tried those? Do you want me to try anything?
I didn't have problem with 2.4, but I had problem with 2.5.
Okay, yeah, I was going to discuss that.
Yeah.
Okay, so if no one else has any issues with 2.2, 2.3, and 2.4, that is, if you can handle it, we can move to 2.5. Problem 2.5. What is the question? The question is obtain an expression for the partial derivative of A inverse with respect to A. That is the question, where A is a second order, tensor. Okay. And they also give a hint. Start with the identity. Start with A inverse, AIK inverse, AKJ equal to delta IJ. That is the hint that they provide. Okay. All right. So here's a hint, and we need to get A inverse, derivative of A inverse with respect to A. So let's start with this quantity and differentiate both sides with respect to AMN, a component of A, a component of A, which is in general not I or K. So that's why we are using M and N as independent indices of that component. So we want to differentiate both sides with respect to AMN. So how will that look like? Partial derivative with respect to AMN of AIK inverse multiplied by AKJ equal to delta IJ. Is this okay? That is, we are starting with this identity, which is like saying multiplying a quantity by its inverse will give you 1, and that 1 will happen only if I equal to j, because k is a common repeating index here. So we are just multiplying a matrix with its inverse for a particular value of I and j. So we're starting with that. Right side is simple. Derivative of a constant with respect to delta mn is 0. AMN is 0. And I can write this derivative of AIK inverse with respect to AMN multiplied by AKJ plus AIK inverse multiplied by partial derivative of AKJ with respect to AMN equal to 0. Couple of things here. One is you don't need this. You need this. You need this because this looks of the form partial derivative of A inverse with respect to A, whereas this is a number that can be expressed in terms of delta functions. So we want to keep this and we want to get rid of the second term. We want to keep the first term, get rid of the second term. How can you express this second term in terms of delta functions?
Delta Km delta
Multiplied by delta
Jn.
Correct. That is 1 second. I need to do this sign in, otherwise. Yeah, okay. All right. So a partial derivative of a kj with respect to a mn equal to delta km multiplied by delta jn. Right? Because this quantity, it's not just about a kj and amn. They are independent of each other unless k is equal to m and j is equal to n. If they are independent, then it means their derivative with respect to each other must be 0 unless they are really the same quantity. Okay. So this is, I can replace this quantity with using these delta functions. So if I go back to equation 9, I'm going to start with this and replace this this quantity in the square with delta functions. Are we together so far?
Yes, sir.
Yeah.
Yes, sir.
Mark, are we okay?
Yes.
Yes. NC?
Yes.
Yes, yes.
Okay, thank you. Okay. PowerPoint is frozen. Let's see what happens. Just give me 1 second. It's saving something and it's not allowing me to change anything. So you can continue doing this. So replace the term in the square with delta km and delta jn and start simplifying. Ultimately, you want an expression for the first term without the akj. You want the akj to be replaced, and then you want this term to be expressed in terms of the remaining quantities. So keep working on that while my computer catches up. All right. Okay, so now I'm going to write partial derivative of aik inverse with respect to amn multiplied by akj plus aik inverse multiplied by delta km delta jn equal to 0. So I have to set k equal to m, right? That's the idea of delta function. So this is aim inverse delta jn, and then this is equal to 0. Okay. So now we need to eliminate this quantity. To eliminate that quantity, we are going to start with, or we are going to do delta mn a k j multiplied by a j aj, let's say l inverse plus a im inverse a JL inverse delta JN equal to 0. What is this quantity? How do you write an expression for this quantity? Does it look familiar at all? We just saw this quantity somewhere. Can I say this quantity is delta KL?
Yeah, it was like the similar to hint.
Right, it's exactly the hint. I'm just using the hint one more time. I use that identity as the starting point. And now here I'm again using that hint to replace this quantity with delta KL. Okay, because delta KL will allow me to just make this simpler. So I can write partial derivative of A IK inverse over AMN delta KL equal to or equal to negative of A IM inverse A JL inverse multiplied by delta JN. So here on this side, I have to set K equal to L or L equal to K. So I'll write partial derivative of I L inverse AMN equal to, I have to set J equal to N. I don't want J, I want N. So I'm going to write this is minus AIM inverse minus ANL inverse. Okay, so I have IL, MN, IM, NL, and I'm just going to change the index and say partial derivative of Aij inverse with respect to AMN equal to negative AIM inverse AI or ANJ inverse. So this is the final expression. The partial derivative of A inverse with respect to A is a tensor whose components are minus AIM inverse, ANJ inverse, EI, EJ, EM, EN. So this is a tensor of rank 4 or order 4. So let me ask you a related question. If you take a tensor and differentiate it with respect to a scalar, what is the resulting quantity?
Vector.
The resulting quantity is also a tensor. So this is like writing partial over partial S, Aij, EI, EJ. So this is partial over Aij with respect to S multiplied by EI, EJ. This is again a tensor of rank 2. If you do a tensor with respect to another vector, what is the order of the resultant quantity? So you would in general write A is equal to Aij, EI, EJ, and you would write V equals VK, EK, because there is no reason to think A and V share some common components or common directions. In general, they are independent. So you would write it as Vk Ek. So you would start by computing Aij over Vk, and you, depending on what properties A and V may have, you may write out some expression, but that expression will be a tensor of rank 3 in general. And if you do the same logic for A with respect to B, this is a quantity whose components are Aij, Bmn, which is what we did, except in our case, A, or the numerator, was A inverse and denominator was A itself. It's a special case that we did now, but in general, this will be a tensor of rank 4. Does that make sense? Okay. All right. I do hope to return to that problem we skipped, but before that, so we saw 2.5. What else is on the homework? 2.14, 15, and 17. 14, 15, 17. Now, if you had seen problem 14, we already tried that in the class. I just did the first eigenvalue and the eigenvector, and I asked you to try the other two. So I hope you would be able to do that. Anybody has a question on problem 2.14? Yes, no? Can you handle it by yourself? Yes? Okay. NC, are we okay? Morteza?
Yeah, I haven't tried that one yet.
Okay, it's really straightforward. You just have to get the 3 eigenvalues and start getting the eigenvectors corresponding to the second and third eigenvalue. I did the first eigenvalue in class. Okay.
Okay.
Problem 15 is problem 15 has a lot of subdivisions, but it's actually quite simple if you just have to do index notation. Okay. So part 1 says write out explicit expressions for the following indicial expressions, and then part 2 says expand and simplify, and then part 3 says write out the following expressions in indicial notation. So maybe we can try something here. How about we try I don't know what to try. Do you want me to try something, or is it something that you can do on your own? Okay, I don't see anything as particularly challenging, so I'll not go into that. Problem 17, that's also on the homework. So this is related to some of the identities which we encountered last time. Maybe we'll try one of this. So problem 2.17, take a look and suggest to me which one should we try. Problem 2.17. I'm going to start with, let's say, part 2. Prove that divergence of the curl of U is 0. Prove that this is 0. So what can we do? So to give you a starting point, by the way, anybody has already done this part and want to just say what they did? Okay, I'm going to start with this. The curl of u is the partial derivative of u with respect to xj with a negative sign cross ej. This is given in the book, and this is coming from page 59. Page 59. This is basically like a definition of curl. So this is nothing but if I write u as partial over partial xj, ui, sorry, ui ei cross ej. This is minus partial derivative of ui with respect to xj, ei cross ej. Ei cross ej is negative partial derivative of ui with respect to xj, epsilon ijk ek. This is equal to epsilon ijk ek. Because magnitude or components of ei and ej are just 1 and 1, so I don't have to write it. I just multiply by ek. Are we together so far?
Yes.
Yeah. Others? Okay. All right. So I'm going to write this in the next page. Del curl of u is equal to negative u I over xj epsilon ijk ek. You can in fact use this as a starting point wherever you encounter curl of a vector. You can just use this and just go from here. And then you want to know what is the divergence of curl of u. So for that, let's see what is the divergence vector. As an example, let's say if you want del cross v, that would be partial over partial, we'll say xj of v dot ej. This is the divergence operator. And if you are curious where to find this, this is equation 2.92 from the book. And if I can write v vector is vi ei over xj dot ej. So this is nothing but partial derivative of vi with respect to xj delta ij, or this is partial derivative of vi with respect to xi. This is just to recap what is divergence. Okay. What you want is not this quantity. You want the divergence of a vector, which happens to be the curl of a vector u. All right. This, can you identify this quantity? What is this quantity? This quantity is the component of the vector. So I can write vk is nothing but minus ui xj epsilon ijk. multiplied by ek. So I'm just saying v, the vector happens to be this vk multiplied by ek. So if I want to write the divergence of curl of u, that is like writing partial derivative of vk with respect to xk, that is partial derivative of with respect to xk of vk, which is minus ui over xj epsilon ijk. Ui over xj epsilon ijk. How do we prove that this is equal to 0? So this is like writing minus epsilon ijk second derivative of ui with respect to xk and xj. Yes, what were you saying? Did somebody say something? Okay. So how do we prove that this is equal to 0? You can, if you expand this out, this will be 0 obviously, because you have second derivative with respect to of ui with respect to xj and xk, where k and j are interchangeable. But you do know that when you interchange j and k, you get a -1 for one permutation and +1 for the other permutation. Does that make sense to you, what I'm saying?
Yes.
So I'm going to write negative of epsilon ijk second derivative with respect to u of ui, and this is xj xk. Okay. So if I write, okay, what I said makes sense, but how do we put it in writing? What do we do next? So you can say epsilon.
We can say like dou square ui by dou hj and dou xj is equals to dou square ui by dou xk and xj. Since
Okay, I didn't fully understand what you said, but I'm assuming you're saying something like this. Epsilon ijk second derivative of ui with respect to xj xk is equal to negative of epsilon I kj second derivative of ui with respect to xk and xj, which only means that you're going to get
0.
yeah, which only means that this quantity is 2 times epsilon ijk second derivative of ui with respect to xj and xk is 0. So this quantity is nothing but 0. So if this is 0, then we have proved the divergence of the curl of a vector is always 0. Does everybody is okay with this step? All I'm doing is writing epsilon ijk is just negative of epsilon ikj. That's obvious, right? It's the odd permutation. So which means 2 times this is 0, and this is possible only because of the term here happens to be the same. If this term weren't there, then we can't prove this identity. So it's not always true. It's only true because we are taking the divergence of a curl. Okay. Everybody okay with that? What is a Samyak? Mark?
Yes.
Yes.
Yes, can we stay on this slide for a second longer though?
Yeah, sure.
Okay, thank you.
Okay, good. So now, if I look at the other problems within problem 2.17. So we just proved number 2, which is divergence of curl of a quantity is 0. Let's try number 4, which is the divergence. I'm sorry. The divergence of a tensor dot a vector is equal to the divergence of the transpose of the tensor dot vector plus the tensor double contraction gradient of the vector transpose. We have to see what is this double contraction, which I don't think we have encountered frequently before. So some basics. What is V? You can write it VK EK. What is T? Can you tell me? How to write T in general? Can I write it Tij EI EJ, which would make T transpose to be Tji EI EJ. With me so far? What would be T dot V? That would be Tij multiplied by Vj. Would you agree? You have to dot Ej and Ek, which will give you delta Jk. So instead of Vk, I'm writing Vj. And then you want to do divergence of, okay, this quantity, is this a vector or a tensor? Tij Vj, is that a vector or a tensor? Hello?
Vector.
That's a vector, right? It has only one non-repeating index, I, right? Right. So if I do divergence of this vector T dot V, that is like writing partial of Tij Vj with respect to xk, and then I have to write delta Ik. So that's like same as writing xi. Partial derivative of Ti Vj with respect to xi. Okay. Good so far, not that complicated yet. We just have to prove the right hand side equals to this, or expand this and prove each term is equal to the two terms that will come from here. So I'll start here. Equal to partial derivative with respect to xi tij vj, which is partial derivative of tij with respect to xi times vj plus tij times vj over xi. All right, let's check out something. Let's see if this quantity here, the divergence of t transpose dot v, happens to be the first term. The divergence of t transpose dot v. What is t transpose? That would be partial over partial xk, um, partial over partial xk. Wait, t transpose would be t ji delta jk. So this would be ei ej dot ek. So this will be partial of tji xk ei delta jk. This is partial derivative of tji with respect to xj ei. Okay, tji with respect to, so sorry, this is only the divergence of the tensor. I did that pretty quickly, but does that make sense to you? Divergence of the t transpose is given as partial derivative of tji with respect to xj. Are you okay with this? Take a good look and tell me if this operation made sense to you. Yes, no? NC?
Can you explain it again?
Okay, I'll do it slowly. I kind of rushed through that. So what is the divergence of any vector v? Just for example, no, I'll not use v because v is involved in this problem. I'll say any vector. I'll call it vector x. Oh no, x. Not sorry. Again, x is a bad u. This will be partial ui over xi. Okay. If I want divergence of t transpose, that is like saying partial of with respect to xi, and I should have t ji ej. Now, how do I get this? I know t transpose is t ji ei ej. Okay, so I'm going to do the partial derivative with respect to xk of t transpose and then dot this with ek. This is divergence of t transpose. This is equal to partial derivative with respect to xk. What is t transpose? That will be tji ei ej dot ek. So I'm going to get through this a delta jk. So I have to set j equal to k. So this is equal to partial derivative of tji xj ei. I guess I wrote this wrong here. tji xj ei. Obviously, that makes sense because j is repeating, whereas I is not repeating. So this is still a vector whose components are partial derivative of tji with respect to xj. And now I want to do dot product of this quantity with vector v. So I'm going to write divergence of t transpose with respect to dot v is partial derivative of tji xj ei dot vk ek. So this will be partial derivative of ji with respect to xj vk delta ik. So this is partial derivative of jk with respect to xj times vk. Okay. Now both j and k are repeating, which means they are just dummy indices. So I can write this partial derivative of ij with respect to I times vj. And if I do that, would you object? Both, wherever j appears, I'm replacing it with I, and wherever k appears, I'm replacing it with j. So this expression here is same as this because all I have changed is the dummy index. Can I go back and check if this is the first term that was in the product? Tij xi multiplied by vj. I'm getting this, and I'm getting the same quantity here as well. Okay, so this essentially proves this quantity is equal to divergence of T transpose dot V. Is that okay?
Yeah.
Yeah, okay.
Yeah.
Now let's look at the second quantity, or actually look at the other term that we are required to prove, which is T double contraction, that is T double contraction, the gradient of V transpose. Now gradient of V is a tensor. That is, gradient of V is equal to partial derivative of Vi Ei with respect to xj ej. So this is partial derivative of Vi with respect to xj ei ej. So the gradient of V transpose would be partial derivative of Vj with respect to xi ei ej. And then we are asked to do T double contraction gradient of V transpose, which is equal to, like writing T, let's say Mn Em En dot dot Ei Ej Vj Xi. Okay. So when you do this double contraction, usually you would do EEM dot EI, EN dot EI, TMN partial VJ over XI. This is TIJ partial Vj over Xi. Is this what we have from previously? So this quantity here, take a look. Let's go back here and check if we got the same quantity here. This is T double contraction gradient of V time transpose. So that proves our left side equal to right side. We still want to come back to the problem that we skipped, which is problem 3. Problem 3, epsilon ijk, epsilon mnk equal to delta im, delta jn minus delta in, delta jn. I still don't have any great thoughts right now, but here's what I plan to do, which is work on this problem and update the solution in the same PowerPoint file and post it to you guys through Canvas. So at this point, what I wish to ask you is, do you have enough hints to do all the problems and complete this homework? Look at the problems list except problem 3. Can you do everything else and be able to submit this on Tuesday? And I hope to post the solution to this problem 3 soon, like by tomorrow. Do you have enough hints to do the rest of the problems? Please answer me.
Yes, but I have a question. So
Yeah.
problem number 11 and 12 is for which course? I didn't get it.
Oh, okay.
11.
So if you are a doctoral student, you will be taking 8302. If you're a master student, you will be taking 7302. That is your course number. So only doctoral students need to do problem 11 and 12.
Oh, okay.
So if you are a doctoral student, yes, you have to do that. If you're a master student, you don't have to.
So so that's a now you're explaining I'm a doctoral student, but I think I get the course by 7302.
That's something you might have to check with your department, because usually, at least in mechanical engineering, um, doctoral students have to take the 8000 version and master students have to take the 7000 version. So kindly check. If you are a doctoral student, maybe we have to change your enrollment. I would suggest you do problem 11 and 12.
Okay, because I just look at it and mechanical 7302 is what I got.
Yeah, you have to talk to your graduate coordinator.
Okay.
Yeah, but you know you're a doctoral student, right? So do the problems 11 and 12.
Okay.
Yeah. I guess there are only about 3 students who are doctoral students in the class. Remaining 9 or remaining 8 are master students. Okay. Everyone else, are we okay?
Yes, sir.
Okay. So by tomorrow, I'll give an update on problem 3. Okay. Rest of it kindly complete and it's due by Tuesday. and I'll post these slides and the lecture tonight or by tomorrow. Tonight lecture I can post. Sorry, slides I can post right now. Okay. So, is there anything else? Otherwise, thank you.
Nothing else.
Thank
you.
Thank you.
All right. Thank you. See you all on Tuesday in our regular class in person. Okay.
Thank you, sir.